If you're anything like me, you use your hot glue gun all the time on electronic projects. It works great for temporarily holding things, but also permanently holding things. But if you're like me also, you forget to turn it off and it sits there for hours and hours on hand, getting hot, dripping ooze everywhere on your desk. So what I built today is this little device here, which has a little switch on it, which can detect when we place this on the cradle. And what it'll do is it'll set a timeout of 15 minutes. And then after 15 minutes of it sitting here and not being used, it'll go ahead and turn it off and it'll go ahead and shut that down. I'll show you the countdown is counting down right now from 15 minutes. Now, during that 15-minute period, if you happen to pick it up and use it, it'll switch over to the word use. And then when you're done, when you set it back down, it'll reset that timer for 15 minutes. Now, at the very end of the cycle, the last 3 seconds, you'll hear a couple beeps indicating it's about ready to turn off. If for some reason you're still using it, you can just lift it up and set it back down, and that'll reset the 15 minutes. In addition to that, on the top here, there's a little indentation with a removable tray so that if it does drip and ooze, it'll just go in here and you can easily clean that out. You can cut a little piece of cardboard and put it in there if you want to reuse that, or you can just use a little isopropyl alcohol and dissolve that or dislodge that glue super easily and pull that out. So anyway, this is the project here today, and let me walk you through each of the steps on how I built it. Let's take a look at the components that I'm going to use. The Arduino Nano, I've got a relay, I've got a little display, a couple limit switches, this AC to DC converter, and just an old power cord that I cut off of something. I don't even remember what it was anymore. But at the base of it, it's going to be this Arduino Nano. Now, if you've ordered these, a lot of times you'll see they come with these headers pre-soldered on, but they just take up too much room, and I want to be able to solder directly to the pins so that I can just fit it into a really small case. Now, to take these off, there's I've only found one good way to do it, and the trick is to take some side cutters and cut individually each of these plastic pieces off and then pull those plastic pieces out. Once you do that, you can heat up, add a little extra solder to the top part, and then using some tweezers, just heat them up and pull these pins out. It takes a few minutes to do, but it's honestly not that bad. Now, if you can buy them without the headers, I would just do that. Just be extra careful that you don't pull some of these components off the back. I have in the past, for example, using the side cutters, accidentally cut that little diode off. So anyway, just be careful on that. This is a great little Nano for this project because it doesn't take up a lot of room and it's got more than enough pins for what we're doing. As for the other components, this is just a very straightforward 4-digit LED display. There's nothing fancy about it. This is based off of a TM1637 chip, and those are actually very easy to program. Within the Arduino library, there's a bunch of libraries available, and this one I think is red. I bought a bunch of them. They're only about $1 or so a piece, so they're great to have on projects like this. Now you may notice it's got 2 sets of pins. They're both common together, so you can use whichever side you want. I'm also using this relay. This is going to be what switches my hot glue gun on and off. Now this is going to go straight through the mains voltage. So if you're not comfortable with mains, you might want to skip this project. I'm going to take this little header off because I'm going to solder the wires directly on. I'm going to use the same technique I did on the Nano to get that off. This right here is a 5-volt AC to DC converter. Now this is going to take 110 volts from the power, and it's on this side here. And it's going to run it through this little switch mode power supply, and it's going to give you a 5 volts on the output. Now, these are kind of neat because they've actually got a spot here for a voltage regulator if you want to put one on. So if you wanted to step this down a little bit, you could, or if you just needed some additional regulation, you could. In our case, it really doesn't make any difference because the 5 volts of this isn't going to care if you're a little bit off, although this is going to be switched via the Arduino, and this I don't think is going to have a big deal. And of course, the Arduino already has a voltage regulator because that's going to convert it down to 3.3 anyway. Now this one is going to have the power coming directly in, but as you'll see here when we get to the schematic, there's going to be a spot where that power needs to go to the hot iron itself. So anyway, I'll show you that here in just a minute. And then I've just got these 2 limit switches. Now, these are super inexpensive. They're just called limit switches or micro limit switches. They do have 3 pins on them. We're only going to be using 2 of them, but these are great to have on hand, and they're going to work perfect. So anyway, those are the components that we're going to use. You'll also need a little bit of wire, but that's it for this particular project. Let's talk about the case itself that I'm going to print. And here's the case that I designed. Now I'm going to include the STL files if you want to print one yourself. Now this was my very first version, and I ended up not even printing a second revision. There were a couple minor things that I changed on it, and I'll have in the final STL files those changes. But the way this works is that it's got this little kind of trap door with those limit switches that you can see right there, which I've already glued on. And then when the hot iron sits on it, it closes both of those switches. Now this side over here is going to be where you can put a little piece of cardboard or sponge or something and then capture any drip that the hot iron might have. And I specifically designed this to be replaceable in the event that this gets hot and melts, or if you just want to print a different color or something. It doesn't necessarily need to be separate, but I just thought that was a good design, so I went ahead and created that separate. Now this also, the top comes off. Now I did this for a couple of reasons. One, it just makes the design itself printable a lot easier. I've got a couple of ridges here that go in here to line that up, and it's a really nice friction fit. And then on the flap side, the way this is set up is I have these 2 little pins that I 3D printed, and I went kind of a couple of different ways before I finally decided on this. So it's got a little slit down the middle. My idea is once I'm done, I'll probably just heat that up and spread those out, or maybe put a little drop of hot glue in there. But this ended up working out just fine. So let me take all of these out. I'll show you the case itself. I've got the power here, which is going to be coming out from my hot iron or from my hot glue gun, and then this will be the input, which will essentially be this wire here coming in from the power. On the front here, I separately 3D printed this little piece and put it in there so that the display fits perfectly. I'm probably going to change that in the final design, so that'll just be printed automatically. And then the other thing, and this I really struggled with getting these switches in. I wanted to just glue them in since they're plastic, and the super glue works great for something like this. The problem I ran into is that super glue sucked up into the switch itself. And I ended up using, this was like the 8th and the 9th switch that I ended up gluing in before I got them so that the glue didn't seep in and actually affect the switch. So what I'm going to do, I'm going to put a little ledge on the bottom underneath of each of those for alignment. I think that'll just help from getting it lined up perfectly. Since I didn't have that, I was kind of eyeballing it. And the other thing, if you're going to glue yours in, I mean, you could use hot glue, which would be a little bit easier. Keep in mind, it's not really supporting much weight at all. But what I would recommend doing is putting some glue on the case itself and then putting the switch on. I think that's probably your best technique. So let me put this together and I'll just show you how it works with the hot glue iron itself. So the case is put back together, and as you can see, it's got a nice little clicky click switch on the top. Those 2 limit switches work great to hold it open. This obviously doesn't weigh anything, and it's a very small piece of leverage anyway. And then here's my hot glue iron, and as you can see, when it sits on there, it sits perfectly. The weight of the glue holds those switches down just fine, so that works out perfect. As you can see, I got the nozzle just right for that as well. So if there's any drippage, it's just going to go into here and it can easily be removed. So one other thing to note, if you don't know this, isopropyl alcohol will immediately dislodge any stuck hot glue, and it's a great tip. So if this ends up getting some glue in here, if you just put a little isopropyl alcohol on there, wait a few seconds, it'll peel right off and won't leave any residue behind. So that's the case, and I think it turned out really, really well. I might 3D print this again. I made it a little bit loose. I think I might tighten that up a little bit, but other than that, I think it turned out perfect, especially for the very first try. So with that, let's go ahead and talk about the circuit design itself and how all these components go in here. Let's talk a little bit about the circuit. Now, it may seem extremely complicated, but as we break down the different components, you'll see it's actually not that bad at all. So keep in mind, we're working with live mains voltage, so 110-ish volts. If you're not comfortable with that, you might just want to skip this project. But, honestly, you can build up a lot of this without even interfacing with the live until you're at the very end, and you'll see it's pretty isolated anyway. So we've got the live coming in. That's just going to come in on an old cord that I had. It's already got a plug on one end. That's going to go into the AC-DC converter, which is this guy right here. It'll come in on this side where it's listed live and neutral. Now you should probably track down which is live and which is neutral on that, just to be safe. And then on the other side is the 5 volts. So that's going to come in here, and the 5 volts is coming out, and this is going to go into the V-in on the microcontroller, on the Nano. Now the VN pin is over here, and I believe that runs through the voltage regulator. Well, I could be wrong. I'm not 100% sure. I'd have to take a look at the traces on this. But regardless, this is where we want to bring in the VN for the microcontroller, which will be 5 volts coming out. And then we also want to tie all of our grounds together. So this will be our 0 volt rail or our 0 DC volt rail. And that's also going to be hooked to ground. And we'll see all the other components are hooked to ground as well. Now the Nano, we've got the different pins. So we'll talk about this when we get into the code. But for right now, D2, I've got hooked up to my 2 switches. And again, those are in series. So both of them need to be closed, which makes sense because as we close the lid, we just simply want them both to make contact before we do anything. And then I've got this buzzer, and I did forget to mention this earlier, but the buzzer is just running through a 220 ohm resistor, and it's just a standard piezo buzzer, nothing fancy about that. Well, we'll see in the code where we're actually making the buzz and giving some audio indication when we're about to shut down the circuit. Next, we have our relay. Now, the relay's got 2 sides. It's got the low volt, 5 volt side and the high volt side. And here's the relay I'm using. I'll be taking these pins off here on the side just to solder directly onto it. And then here's the ratings on this. This one in particular, and yours may vary a little bit, but this is going to be safe at 15 amps at 125 volt AC. Now, it is important to kind of note if you're using a different soldering iron. Mine's only going to draw about 1 amp at about 100 watts total, so it's more than sufficient. If you happen to have something bigger or a different soldering iron, you may need a larger relay, so just keep that in mind. Also, these screw terminals are not awesome. I'm going to go ahead and use them on this project, but I'm also going to put some hot glue on it just so they don't come out. These ones just tend to not work awesome. So anyway, the relay is going to be switched on from the microcontroller via pin D4, and that's just going to come in, and then it's also going to have a 5 volt and a ground reference back to the Nano. So we'll take the 5 volt, which is over here, the 5V pin, and we'll use that to control the relay as well as the 8-segment display. Now on the high side, this is going to tie all the way back to the live, and we're going to switch the live. So the live will switch on and off based on whether or not the relay is on. And so that's what's going to actually turn our hot glue on and off. Likewise, the neutral for that is actually just going to come back, and they're just going to be commented in on that AC to DC converter. And then the last component is the 8-segment display. This is nothing fancy. It's just a regular display. It does have a couple different sides of the pins based on how you want to wire it in. So that's going to take 5 volts from the microcontroller as well as ground from the microcontroller, and then it takes 2 pins, and D5 is our clock and D6 is our data, and that is all there is to it. So like I said, it looks a little more complicated than it really is. Now granted, trying to get it into that little box is going to be a little bit of a challenge, but I'm pretty sure everything's going to fit. I did kind of measure it out in the CAD software just to make sure we had enough room to get in and out. So with that, let's go ahead and flip over and we'll talk a little bit about the code that's driving this microcontroller and setting up all the rules for how the hot glue gun is going to go on and off. And there it is. It's all wired together, or at least almost all wired together. This is as far as I would take the initial wiring so that you can test everything and make sure it works. Now, the things that are missing that you might notice is that AC to DC converter. Now, the reason that's missing right now is that we can test this in this current state to make sure everything is wired up correctly, make sure the code works, without needing to use mains voltage. So this is a way to just test everything in advance to make sure that you don't have any problems. Now is a great time to fix it. You don't have to worry about poking anything that might be high voltage. Once we get this all working and we're happy with it, then we can go ahead and add the high voltage and the AC to DC converter. So let me just talk briefly about how I've got this set up. Now, obviously, make sure your wires are long enough to reach around. So, for example, make sure you've got long enough wires for your display to make it to the front, and then also make sure you've got long enough wires for your switches that will go in here. And right now I've got an extra ground. I'm going to end up cutting that off. And then here's that speaker that I mentioned earlier. This isn't going to protrude outside. It's just going to be internally. And then these two wires here, the red and the black, are going to be what hooks up to that AC to DC converter. And this is going to take the 5-volt side coming in and actually power our circuit. At this phase, before we upload the code or do any testing, we can go ahead and use the USB on the Nano in order to run everything. So let me just go grab a quick little power cord and a little power bank, and we can test this out, and I'll show you how it all works before we actually get the high voltage integrated in. Okay, I uploaded the code. I'm going to show you the code here in a minute, but I thought I would just show you how it's supposed to operate before we look at the code. That'll probably help just bring some context to the code itself. Now, this is a little bit swamped out here on the deck, but it'll be fine in real life use. But this actually spells use. It's got U-S-E as part of it. This is indicating that my iron is picked up off of the cradle and I'm using it. So the hot iron is in use. While it's in use, the relay will obviously always be on. But the other thing that'll happen is that this is now going to not be counting down. It's not going to have a countdown timer. It's just going to be in a use state. And then until I return it back to the cradle, it'll just stay in that state. Now, because I don't have this into the box yet and I don't have a switch, the way my switch works is it's going to be connecting this white wire, which will eventually be connected up in series to my switches, and then any ground. So I'm just going to use this ground. So when I touch these two together, it's going to indicate that my iron has been set on that cradle. Now, for testing purposes, I've set my timeouts to be very, very short. So otherwise we end up waiting 20 minutes to see if it actually is going to do what it's supposed to do. So it's only going to wait 5 seconds before it goes through the cycle. So you're going to simulate a very quick countdown and then shut off. So let's go ahead and test this out. So I'm going to close these two together, indicating that I've returned it to its cradle. And now you can see the timer count down from 5 with some beeps, and now it's turned off. Now you can see it says OFF, indicating that the circuit is off and the hot iron is off. Just for display purposes, you'll also know this green light is off. This is just a feedback from the relay indicating that it's in its current off state. So now if I were to pick up my hot iron, again, at this point, the hot iron is completely off, so it may even be cold at this point. But I'm going to pick it up and you'll see it now turns it back into use, and you may have heard that click of the relay turning back on, powering the hot iron. So now I'm going to do another quick test. This time I'm going to simulate putting it down and then picking it up before it times out. Normally the timeout's going to be 20 minutes, but in my particular case it's 5 seconds. So I'm going to cradle it, and then it's going to start counting down. It actually went to 10 seconds, and I'll explain that in a second. Now I'm going to pick it up again, so it's in use, and now I'm going to set it back down in its cradle. It's counting down from 5. It's beeping, indicating that it's getting close. I picked it up again, set it back down, count down from 5, beep, and so on. So I'm going to take this off. I'm going to pick it back up again, so it's indicating in use. Now you'll notice the beep, and this is just for prototype purposes. The beep starts to beep at 3 seconds. So at 3, 2, 1, it just does like a beep, 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 indicating that it's getting close to powering down. So if you're in the middle of a project and you're going to need that hot iron again in a couple of minutes, you would just simply pick the iron up and put it back down, and that'll reset it. Again, in production, it's going to be greater than 10 seconds. But just for demonstration purposes, that's what I had it set to. So those are all the different use cases and all the different scenarios of it booted up on how it's going to work. The only other use case is what happens when you first turn it on. So for example, you're getting ready to start your day. My desk is completely switched. So when I turn the switch, everything gets powered. So what does this do when you first turn on the power? So let's simulate that and we'll take a look. I'm going to unplug it from the USB here. Now it's off, nothing's running. Now I'm going to turn it on, or I'm going to turn my desk on, and it boots up, and it immediately goes into use. Now the reason it went into use and it turned the relay on and it's heating the gun up is because my hot iron is not on the cradle. It was off, just like it is there. Now on the other hand, if it were sitting there, let's simulate it again. So I've got my hot iron sitting right there, and I turn my desk on for the day, and this is what's going to happen. It's going to be off. So in this particular case, because my hot iron is sitting here, and of course I don't use it every single time I turn my desk on, I don't want it to automatically turn on. So by default, if it's cradled and the power comes on, it's going to stay in its off state until I pick it up. Now as soon as I pick it up, so now I want to use it, I pick it up, obviously it's not going to be hot, so it's going to be in use, and then I'm going to just set it immediately back down. Oops. And now it's going to be on, and it's going to be powering, and it's going to immediately time out because of my 5 seconds. But what will happen is, I mentioned earlier that it was counting down from 10 seconds. So the very first time when it goes from its off state to back on, I've got a longer duration, because my thought is that if I'm going to use it, I turn it on, I'm probably going to use it for the next 30 minutes or so. So by default, when it first comes on, it's going to heat up for about 30 minutes, or it'll stay on for 30 minutes before it goes into that countdown. After that, then each time you use it, it's going to set that timer for, I'm thinking 15 minutes, maybe 20. I don't tend to use it for long periods of time, but obviously you can change it to whatever you want. So anyway, that's the prototype. That's the circuit. That's how it's all working. It's working great. If you want to change anything, you sure can. Now that we've seen it work, let's go ahead and grab the laptop and we'll take a look at the code. I'm not going to go through every line, but I'll explain a little bit on how it works. So I set this up as a little mini state machine. I think it just makes things a little bit easier. Obviously, there's a lot of different ways you could do this. So let's just start at the top. I'm not going to hit every single line, but I'm going to just kind of touch on the things that you might want to tweak and change, and then some of the things I might explain a little bit in greater detail. So here's the library I'm using for the display. It's nothing fancy. Any library will work that works with that chip. Here's my pins. So if you do need to redo some of the pins, you sure can. These are what I chose earlier that I mentioned. And then I've got a couple of messages here. This is going to be how I display the off and the use within that 8-segment display. The way this works is you just define the 4 segments with the letters that you want. So on the off, I'm starting with a blank one, and then I've got OFF, and then the use, I actually start with USE, and then I have the blank at the end. I've got some time is in here, which I'm not actually using, and then this gets into my read switches. Keep in mind there's 2 switches, they're in series, so effectively there's only 1 switch, but they both need to be pressed in order for it to change states. Now this is just using a real simple debouncing, and it's just returning what the state is of the final debounced switch. The debounce here is about 50 milliseconds. If you find that that's too short, you can obviously adjust that without really affecting performance. Because it's not something that's going to take a signal over a short period of time anyway, you're going to set it on the cradle and you're going to pick it up. That debounce could definitely be longer. The read switches just simply returns right now the current state, whether or not it's on the cradle or off the cradle. Now here's where I get into that state machine, and there's 3 different conditions. There's whether or not the hot glue is in use, whether it is on, and then whether or not it was off. Now the reason the was off exists is because, if I mentioned a second ago, if the gun was off and it's just turning on, we want to give it a longer period of time before it times out. So that's the only reason for that. And then I've got some initial seconds here. I passed over those earlier. They are somewhere. Here they are. So right now I'm just using a couple random values, so 10 seconds and 5 seconds. This would more likely be 30 minutes and maybe 20 minutes or 25 minutes, but you can set it to whatever you want. So here's the setup, nothing fancy in here. I'm defining those pins. Also keep in mind we want to use that internal pull-up for our switches. So make sure you define that properly. Output is just, or buzzer is just an output, relay, nothing fancy there. One trick on the relays is, or on anything for that matter with the digital output, if you set the pin, before you even define the pin, if you set it to a state, in this case I'm setting it to high, high is going to be off in this particular relay. Your relay may vary, but I think this is how I've seen all of the relays that I've ever worked with. If you set that high before you define it as an output, the initial on state will be high. So just keep that in mind. Set display brightness. This is just turning it full bright. And here I'm just checking, as I mentioned earlier, about that when it boots up. What do you want it to do? In my case, if it's on the cradle, I want it to stay off. If it's off the cradle, I want to immediately turn the circuit on. So those are what those two do. Now here in the loop, all I'm doing is I'm just reading the state, and now I'm checking all those different states. Now the first state is the switch is low, indicating the gun is in the cradle. And in that case, we just simply need to know, if the gun is also in use, in which case you were using it and you just put it on the cradle. We need to flip all those states. And we need to start our countdown. And this is where that was off occurs, where we want to use the longer time versus the shorter time. And then lastly, we're just going to display the number of seconds. So if it's going to be a countdown from, for example, 30 minutes, then it'll start in seconds and start counting that down. So the display, which you saw at the very beginning of the video, is doing that countdown. And then if the hot iron is on, so if it's currently on and you set it into the cradle, we just simply need to reset the timer on that. So each time we set it back into the cradle, it's going to reset that timer. And then lastly, it's going to do this buzz as it gets down to the last few seconds. So this is actually controlling how often the display gets updated. In this case, I've just decided to update it once per second. There's really no reason to do it any faster than that. And then when the seconds is less than or equal to 0, so it's essentially got to the end and we want to turn it off. In that case, what we do is we change it to the hot iron is on, is now false. And then we turn the relay off by setting its pin to high. And that again shuts the relay off. And then lastly, I'm just updating the segment to say off, OFF. Now, the second main case in our little case machine here, our state machine, is that the gun is in use, or the hot gun is in use. Now, in this particular case, we just simply need to go through and make sure everything is correct. So the gun is in use, you've picked it up, but the circuit is off. So in this case, it's already timed out, or it's just been initially powered on. So in that case, what we need to do is we need to turn the relay on. And by doing that, we set it to low. And then we set up our states. We initialize the clock, and then I set that segment to use. And then the last one here, which is you just picked it up. So what happens when we just pick it up off of the cradle is we want to reset the timer so that it doesn't time out, because we've indicated that we're just using it, and then I update the display to use. And then there's two default cases in both, which is just, do nothing because there's nothing to do. And so those else's don't need to be there, but just for consistency's sake, it just makes the code a little bit cleaner. So there you go, about 200 lines of code. It's very, very straightforward when implemented as a little state machine. So let's take a look at the final version one more time once I get everything put together into its case, and we'll walk through it in production. I want to show you real quick what it looks like before I put everything back together, because obviously I got to update the code so that it has a longer time period, and I got to tuck everything in, and I'll probably put some hot glue on some of these joints just so they don't wiggle loose in there. But I thought I'd just do a real quick demo with my final version here. So I'm going to just hold my thumb on this so that we can see it. But obviously, here's the hot glue gun. While it's sitting there, it's currently in its off state. When I lift it up, it's going to go back into use. Now in this particular case, it turned the relay on because it was off, and it's heating up. Now normally you would set this back in the cradle, and it's going to do the countdown. Right now it's still set to 10 seconds, so it's actually going to turn off pretty quick. But as you can see, once you lift it up, it goes ahead and triggers it, and then when you're done Using your hot glue, you can just set it back on, and again, it's going to do that 5-second countdown with the beeps starting at 3, and then it's going to turn itself off. So I don't know if you saw or heard, but the relay clicked off as well. So now the hot glue gun is in its off state. Again, super short period of time just for testing purposes. But anyway, this is how it all works. I'm going to go ahead and unplug it real quick. And I'm not going to take everything out just because it's a pretty tight fit, but I'll just kind of show you a little bit on how I've got it in there. So I've got the display tucked into the front, and it's a pretty snug fit. I might put a little bit of hot glue on that. And then I've got my switches wired up. You can see I've got a white wire here at the bottom connecting the two together, and then one side's ground and the other side is going back to the microcontroller. I've got a couple zip ties on here, which I'll trim later for strain relief on the cables because I want to make sure they don't pull out. But here's my live coming in from the wall, and this is the live, or the hot glue coming out. Now keep in mind, I did actually cut the end off the hot glue. So if you don't want to do that and you want to be able to take your hot glue gun with you, you could technically put like a jack or something on the back that you could plug it in, something like this. But in my case, I really didn't care. I'll never use this hot glue gun anywhere outside of using this device as well. So here's my microcontroller just kind of floating around. Here's the relay. So I've got those wired in. The black and the brown wires here are the live, and this is what's being switched through the relay. And then down here is the little AC to DC. Now I did put a piece of Kapton tape over it just because I didn't want anything to touch out on the high voltage. Again, since this is live, I just didn't want to take a chance. I will physically glue this component as well as the relay to the bottom of the case so that it doesn't move around, but also it won't ever be able to short out. And then here's that buzzer. Again, I'm not going to have it come out anywhere. It's just going to kind of hang in there. I don't think it needs to have a hole in the case at all. But anyway, that's how it all kind of tucks in there. Like I said, make sure you put some strain relief for your cables. You don't want to accidentally kick it and pull one of those cables and break one of those connections. A couple spots where I am going to put some hot glue when I'm done is right across these connectors here so they don't come loose. And then I'm also going to do the same here on the live on this side, just so those wires don't break loose. When you do solder things into boards like this without any ability to do any strain relief, they do tend to be very brittle. If they wiggle back and forth, they'll break pretty easily. So wherever possible, like on the connectors to the switch, I always run heat shrink, and that'll just provide some additional strain relief on those. So anyway, there it is. I'm going to go ahead and update the code so it's got the correct timing on it, and I'll tuck all this in. And once I get once I get it all working with the hot glue so I can heat my hot glue gun up, I'll go ahead and hot glue all those in, and then maybe we'll come back for one last view of it. Well, there we have it. There's everything all done. I've got the code updated. I've got everything tucked away nicely inside. I put a little cable tie on it. I got everything kind of hot glued down so that nothing shifts around, so the wires don't break. I updated the code to be 25 minutes on the initial heat up when you start it, and then 15 minutes between uses. So if I were to take it off and then set it back on, that would reset that 15-minute time period before it goes ahead and times out. Now, you've already heard it time out. You've already seen how it shuts off, so we're not going to wait 15 minutes to do so. But I will show you real quick. If I unplug this, how everything fit nicely inside. I've got the microcontroller tucked away up here. I'm going to put a piece of Kapton tape behind it just so nothing shorts out, but it also is very easy to access if I do want to update the code. And then the little door here pops off, and then everything is tucked away nicely inside. You can see where I've put a little bit of heat duct or hot glue over those connectors just so that they never come loose, and it's good and solid inside, so nothing shaking and rattling around. And then I've just got my little speaker tucked away in there as well. So there it is. Everything worked out perfect. I really like the way it came out. I like the way the case turned out. I like the way the display worked. I think it just is going to be a super helpful tool. So if you enjoyed that, let me know. If you have any questions, let me know. If there's some other variation on it that you end up building, I'd love to hear about it. Thanks.